Hey, Will. We had to make 2 videos because Colin broke something. We had so fine. You know what? I bet honestly that Will's literally not gonna watch this. So
Definitely not.
Here we go. I gotta practice. I pledge allegiance to the flag of the United States of America. In case you
You
forget
still
it.
might miss it. What? Actually, I think what's funny is I think Miss Michaels was in the room, and she said, "That's that. It's on the wall."
I don't know. What are you talking
Right,
about?
on the wall.
Oh, I got 4. Open them. Yeah, because
It's because I never actually saved.
okay, we're good. We're good. Should this done this? I did this drink for 3 minutes. Yeah, see, that's what it is. Yeah, can we review energy? Because I don't remember that at all, too.
We will. We have a whole chapter called
29. What do you get? I don't know what Colin get. Ooh, we got 34.
I think I win.
Yeah, you're close to the win. I got 29. That's totally fine.
There's some rounding.
Just some rounding errors, yeah. You can just go out of that. I don't know if you can be 4 off from rounding, but
Oh, he did 19.
very good. Oh,
Arrow board.
This one?
Yeah.
We're gonna do purple. Okay. Let's see here. Here's all we hustle. Oh shit. Oh boy. Okay.
I like your coffee.
Thank you.
I think it too. That's good.
Is that YT?
This should be an A.
What is it? It's like a 90.
Oh,
That's an A, Will. Is that mine or yours?
This is mine.
Sure. Both are flawless, perfecting masterpieces. Chisel, perfect.
Whoa, time on the field. Is there initial velocity?
Well, don't we have to find how far from the bottom? So I'm just going to displacement.
Okay, but you need initial velocity to go to displacement.
Oh, really?
Anytime you take the integral, you're going to tack on the initial condition. No, you don't need to erase anything. You just need to tack it on.
Okay.
So how fast is it going? That's why I was asking, is this the Y direction or the X direction? Traditionally, we separate with 2 different directions. You seem to be totally skipping that step. So is this acceleration in the Y direction or the X direction?
This is B in the Y direction.
Okay, so this should be A sub Y, B sub Y. And then we're going to know what the velocity was at the very beginning in the Y direction.
Yes.
And what was the velocity in the Y direction at the very beginning? Because she hit it like Katya did.
You guys get 58.
They did not. They got 9.8.
9.8.
They broke up 19.6 in the components, and they got you signed it.
Oh, this is still related to number 4.
And yes.
Oh,
this is-
see.
you hit the ball like Katya did. So the initial velocity would have been 9.8. Yeah, good. 19.6.
Yeah.
30 degrees. There you go. Yeah. So what's the? So you're gonna have to tack on the initial velocity in the y direction.
Yeah.
So you said the trepidation.
No.
Remember, we're just going to write plus the initial condition, plus, in this case, 9.8, to the top thing you wrote up there.
Okay.
I don't know what you're doing now. Now, pause a second. It's clear you don't know what's going on.
I did.
If I plug in 0 into that first expression before you wrote the plus 9.8, I would get 0 initial velocity, right?
Yeah.
The thing didn't have 0 initial velocity.
It had 9.8.
And the problem is that if I have acceleration, it doesn't tell me how fast it's going to start the problem. So if I tell you the acceleration is negative 2 meters per second squared, I'm talking about a car that's already moving forward. Don't look at the paper anymore. I'm talking about something completely different. I've got a car moving forward at 20 meters per second. And I slam on the brakes. We'd say the acceleration is negative 2 meters per second squared. Let's say. If I say that, and you forget about the initial velocity, what do you think the car is doing?
No, it's not moving.
It's initially not moving, and then goes backwards,
Yeah.
right? That's not what's happening, right? So you have to tack on the initial velocity. Acceleration cannot tell you the speed of the car at the beginning. You must tack that on. That's your job. Okay? Got it?
Yep.
All right. So now that you have the velocity, you can move to displacement.
Oh, by the way, I have no idea how to do question a week, so we should leave that. Yeah, but we get home so late, and I go to sleep.
You don't go to sleep. You sit and play 3 hours of games, and then I try to go to sleep.
No, well, sometimes, yeah. Nick is like, let's do another game. Right. Yeah, Nick will be.
And then you just like,
Doesn't he need to sleep? He can hardly walk now.
that is true. Walker, you need to promote his sleep. We need him Friday.
Why are you doing that?
You know how Nick's going to sleep.
Oh, wait. I'm not sure.
Okay, then let's do it.
Okay.
We'll figure out what the answer is.
It's 9:30.
This is the question I think Natalie had, but she doesn't know yet.
Wait, why is it 20 seconds? Not even 20 seconds. What are you doing? Stop. What is that?
I honestly don't know.
No, where do you get .045? Did you get that? What's that? What's going on?
So a quick question, Max. This was launched off a 40-meter cliff, and you just told me it lands negative 190 meters below the ground 20 seconds later.
Yeah.
I'm going to object to that.
On what ground?
On the fact there is grounds.
Yeah.
My grounds are there is ground.
That's the thing.
So what should we have done instead, which we've always been doing, instead of put 20 seconds in there just to mess with you?
We solve for T.
We solve for T is what we normally do in this situation. I'm going to do my Casio because I can't do it that much. Can't do this problem. I've got the rudimentary Casio. It does the graphic calculator. Too many breaks.
Right, I just need to get the signature. And I can just say things. Whatever I want, right? There's no limit.
There's no limit.
It's pretty much.
There's another group too.
What? I'm gonna just free pizza at lunch. I'm feeling that everyone goes if it was no pizza, that'd be hilarious. Great.
Okay. Which sides?
Just takes the week from me.
Like, hey, this underestimates. Sorry, pizza. That's a good plan.
Or, oh, I see the sushi.
You say there could be sushi, but there might not be. If I were to close to this, interesting. Oh, okay.
Not sure what time. I got like 15.96, negative 4.54, and then negative 11.4.
Well, those are two
Thinking
negative answers and a
positive.
positive answer. Which one is the likely?
The positive.
right one? Even if there was two positive, you pick the lower of the two because it doesn't hit the ground twice.
If it bounces,
Okay.
Well, but then it's not going to follow the equation just like that.
unless we use some calculus. Right. Hey, are we gonna do things bouncing in this class?
No.
No? Is it too hard?
No, it's too easy.
What? Oh, okay.
You're bouncing things and triggers again.
Turn this form into Miss Groff and Miss Divine. Or Miss Divine. Hey, where's Miss Divine? Where's
This crossroom?
oh,
It's like the room below this one.
Yeah.
Wait, can only seniors do it? Is that a rule?
Yeah.
That's a stupid rule.
Why? You want
Juniors
freshmen
should
to
do it. Yeah,
Oh my
freshmen
God.
should do it. They forced freshmen to do it. Oh my god.
271.2 meters. Nelly, where you at? Is it okay?
Yeah, I got that.
Question.
I tried, okay?
To how fast?
Whoa. Look at that energy.
Now, like, interesting question about energy.
Should I not?
How is this ball getting lift? Doesn't say so in the problem, does it?
No.
Could there be an energy here that I could be not accounting for? Specifically, the way golf ball gets lift is if you hit it with some spin,
Mhm.
it grabs the air and shoves it downward
Centripetal energy.
and reduces its speed, its spinning speed.
Centrifugal.
Therefore, there's a whole other bunch of energy we don't want to consider. So we may want to stay away from energy in this
No,
problem.
go, Max, go. Make it work. Oh, you have 1 minute. You're on a time limit.
You've been doing this for 14 minutes?
Dude, I didn't do this problem at all.
It's alright.
How
Part
fast
2
is it
coming
going?
soon, Will. Part 2. Don't worry, we'll be back. Alright, bye-bye.